In the last lecture of a linear differential equation with constant coefficient, so we study how to find the complementary function of the differential equation when the roots are repeated roots are different and complex roots. But also we study there what is the particular integral. So this is one part of the complete solution. So how to find the particular integral here? So method of finding PI, particular integral, PI. Okay, so particular integral when x is equal to, so that is the right hand side, is equal to e raised to x. So if x is equal to e raised to x, then how to find your particular integral? Okay, so let us consider the linear differential equation. So d raised to n plus p1, d raised to n minus 1 plus p2, dn minus 2, just a minute, p2 dn minus 2 plus and so on plus pn y is equal to capital X. Okay, capital X. Here, where what is x? X is e raised to x. X is e raised to x. Then what is the particular integral? Then pi is equal to pi, particular integral is equal to, yesterday we learned how to find particular integral. So that is f of d y is equal to x. Then what is the y? Y is equal to 1 upon f of d x. So it is y 1 upon f of d x. So this is the particular integral here. So particular integral is 1 upon f of d x is equal to, so what is x? So we write here directly x is equal to, so this x is equal to e raised to x is equal to, so what is the particular integral? So particular integral means, so find out the particular integral means remove the derivative operator d. So we get here 1 upon f of a e raised to x. So we replace a, we replace d, we replace d by a. So we get solution here. Derivative operator is removed. Okay, so we replace d by a. So we get f of a. So this is the particular integral. This is the particular integral. So how to find that particular integral? So so let's take a proof of that. So how to find this particular integral formula? Okay. So since what is the d of e raised to x? D of e raised to x means what is the d? D is a d is a operator, d by dx. D by dx e raised to x. So what happened here? So that is the derivative of this is e raised to x into derivative of x is a. Okay. Similarly, what is the d square? E raised to x is what? Again take its derivative. So similarly we can find here a square e raised to x and so on. What is the nth derivative? D raised to n e raised to ax is equal to a raised to n e raised to ax. It is very simple. So what is the derivative of e raised to x? is a into e raised to x. So what is the d square? Second order derivative. Okay. So d square means first order derivative is this. Again we take derivative of that. So that is a square e raised to x. Okay. Then what is the f of d? Therefore, with f of d e raised to ax. Okay, f of d e raised to ax. So this can be right here in the form. So what is f of d? So this is f of d. So this is f of d. F of d is this. This is f of d y x. This is f of d. Okay. So what is f of d? F of d is this. So what is d raised to n? D raised to n. D raised to n is a raised to n. D raised to n is a raised to n. Plus P1. What is the d raised to n minus 1? Similarly, so that is a raised to n minus 1. Plus P2 and so on. A raised to n minus 2. Okay? A raised to n minus 2. And so on. Pn. So e raised to x, e raised to x. So this is taking here e raised to x. Okay, e raised to x. So d raised to n, right here a raised to n in this equation. So that is f of d. So we get this. So what is this? If we call this is as a function of d's, so similarly we say this is f of a, function of a, e raised to ax, e raised to ax. So what happened here? So therefore f of d e raised to ax is equal to f of a e raised to ax. Okay, we get this. So by operating by 1 upon f of d to both sides we get. Operate here 1 upon f of d and here also. So 1 upon f of d into f of d e raised to x. Okay, and this is the algebraic factor, so that is f of a taken out here. So this is 1 upon f of d, operate 1 upon f of d to the both side. Operate 1 upon f of d to LHS, also to RHS. But here f of d is a derivative operator. Okay, f of d is a derivative operator, and 1 upon f of d is an integration operator. So this is a derivative operator and this is integration operator. But the derivative operator and integration operator, they cancel each other. Okay, so but 1 upon f of d and f of d are inverse operators. They cancel each other. Inverse operator, this is a derivative operator, this is the integration operator. So they and both are inverse operator, they cancel each other. They cancelled each other. Okay, so this is get cancelled. So what is remaining here? E raised to x. E raised to x is equal to f of a into 1 upon f of d e raised to x. Okay. So now, so after solving this, we get here. So now, f of a is algebraic expression. There is no d, and this algebraic equation not equal to 0. F of a not equal to 0. Then dividing this equation by f of a, dividing this equation by f of a. So what happened here? So this is dividing by f of a e raised to ax dividing by f of a get cancelled here. So 1 upon f of d e raised to ax. Okay. So this is the particular integral. So see here. So what is the 1 upon f of d e raised to x? 1 upon f of d e raised to x is equal to 1 upon f of a e raised to x. 1 upon f of a e raised to x. Hence we prove this result here. Okay. This result again. So what is the particular case of that same result? Okay. What is the particular case? So why we observe here. So what is the particular case? Particular case. Okay. So case 1 here. Okay, particular case. This method get fails when f of a is equal to 0. If so, what is the particular integral? Putting d is equal to a, so we get solution. But if f of a is equal to 0, then what happens? So this method get fails. Putting d is equal to a, d is equal to this a here, and if f of a is equal to 0, then this method get fails. Get fails here. So why f of a becomes 0 here? Because there is a factor. So that is d minus a. D minus a is a factor. Of f of d. Okay, f of d. So what is this? So f of d is equal to. So f of d. So this, what is the f of d? F of d is this. So there are n factors. So d minus factor taking out. Why taking out d minus a factor from f of d? From f of d, d minus a factor taking out from f of d, because that factors, if we putting d is equal to a, becomes 0, and we get f of a is equal to 0 here. So we taking out, there are n factors. So this is also one factor of that equation, auxiliary equation. So we taking out d minus a. Okay, f of d is this, and remaining is called phi of d. Remaining is called phi of d. So if we put d is equal to a, then we automatically get, so that is a minus a 0, so this is 0. So we taking out that factor, which factor making f of d 0 here. Okay, so what is the particular integral? By using this formula, pi is equal to 1 upon f of d e raised to ax is equal to, what is f of d? F of d is this, d minus a phi of d e raised to ax. So here phi of a not equal to 0. Not equal to 0. F of a is equal to 0. Okay. But phi of a is not 0. We consider. Okay. So by using this formula, put d is equal to a. So we get f of a. Put d is equal to a. So we get 0. This is 0. Okay. So what is this? By using this formula, put d is equal to a. This a. So here this is putting as it is d minus a, and putting d is equal to a. So 1 upon phi of a e raised to x. We can't put d is equal to a in this factor. So we keep as it is. Okay. So this is equal to 1 upon phi of a into 1 upon d minus a e raised to x, And what is the meaning of 1 upon d minus ax? So in the last lecture we have to take that. So what is the meaning of that? So this is 1 upon d minus ax is equal to e raised to ax. E raised to ax integration of take e raised to minus ax x dx. So this is the okay. This is the formula here. Okay. So using that formula 1 upon pi as it is. Okay. So what is this? What is this? D minus a, D minus a. So that is e raised to ax integration of. Then e raised to minus ax. Now what is x? What is x? X is this. So this is e raised to ax dx. Okay? So this is equal to 1 upon pi e raised to ax. So e raised to minus x, e raised to x. So that is e raised to 0. So that is 1. So that is dx only. So therefore 1 upon pi e raised to ax into x. Okay? If the factor, which factor d minus a, that factor making 0 when putting d is equal to a. So this factor repeated 1 times. If the factor repeated 2 times, then what happened? So again we solving here. Okay? So d minus a is the factor repeated 1 time. Take repeated 1 times. Okay? If this factor repeat 2 times, then what happened? Then what happened? Okay? So what is the next? Okay, if d minus a, just so remember that answer here. Okay, this answer. If d minus a, if d minus a repeated twice. So this factor occurs 2 times in f of d, then f of d is equal to d minus a bracket square. And what is this remaining? So what is, so d minus a is, there are n factors. So d minus a repeated 2 times in this equation. So then d minus a, and what is the remaining there? So which is called psi of d. So what is the particular integral? So pi is equal to 1 upon f of d. X is equal to 1 upon what is f of d? D minus a bracket square psi of d. So x is what? X is what here? E raised to x. So e raised to x. Okay. So solve this particular integral here. Put here d is equal to a by using formula. Put d is equal to a. But we can't put d is equal to a in this factor. So we get here psi of a. So this is a function of a into 1 upon d minus, putting d is equal to a, we write here, so d minus a bracket square e raised to ax. Okay, so we solve easily by using yesterday formula. So it is easily, so we can directly write here. So what is the solution? So this is 1 upon psi of a e raised to ax into x square by 2 factorial e raised to x. If the factor d minus a repeated r times, then what happened? If the factor repeated r times, d minus a repeated r times, d minus a repeated r times. Means d minus a raised to r. Then what happened? So we directly write here 1 upon psi a e raised to ax x raised to r divided by r factorial. So this is the particular integral. So we take example, very simple examples and finding complementary function and particular integral in the case when the right hand side x is equal to e raised to ax. So we take a very simple example. Let us take a very simple example. Solve. Example. Solve. Okay, solve. dqy dx cube dqy dx cube minus 3 d2y by dx square dx square plus 4y is equal to e raised to 3x. Okay, so solve this differential equation. Okay, so what is the solution? By using operator d, capital D, so that is d by dx, given equation can be written as d cube. So d is equal to d by dx minus 3d square plus 4 y is there. So that is e raised to 3x. E raised to 3x. So how to solve this? So what is the complete solution of that equation? Is complementary function plus particular integral. Okay, so the auxiliary equation is what? So d cube minus 3d square plus 4 is equal to 0. Okay, so it's so very simple. So find out the factors. So this is third degree equation. So that is the d cube minus 2d square minus d square plus 2d minus 2d plus 4 is equal to 0. So this equation can be written in this form. So minus 2d square minus d square is minus 3d square. 2d minus 2d get cancelled and 4 as it is. So okay, what is this? So d square common out. D square common out. So d minus 2 in bracket. So again minus d common out. D minus 2 minus 2 d minus 2. Okay, so very simple. So therefore d minus 2 common out. So the remaining in next bracket, so that is d square minus d minus 2 is equal to 0. So therefore d minus 2. So what are the factors of d square minus d minus 2? So that is the d minus 2 into d plus 1. So factors of this equation, quadratic equation are these. So is equal to 0 here. So what are the roots? So d is equal to 2. So this is equal to 0. D is equal to 2. So that is the 2. D plus 1 is equal to 0. So d is equal to minus 1. So this is minus 1. Okay. So these are the roots of this auxiliary equations. Then what is the first part? Complementary function. See here, complementary function is equal to, here the roots, the root 2 is repeated. The root 2 is repeated. Then what happen here? Okay, repeated. So that is, if m1 is repeated 2 times, then what is the complementary function? So that is c1 plus c2 x. Okay, if root is repeated 2 times, then we write this into e raised to m1x. What is m1? m1 is 2. That is m1x, that is 2x. Plus c3 e raised to m3x. What is m3? Minus 1. So minus x. Okay. So we saw those examples in the last lectures. So this is a complementary function. So what is the, now PI, particular integral. Now particular integral. What is the particular integral? PI. So that is 1 upon, what is the formula? 1 upon f of d is into x. So this is a particular integral. So what is f of d? What is f of d? F of d is this. F of d is this. F of d. F of d. So that is a d cube minus 3d square plus 4. What is x? X is this. E raised to compare to the standard equation. E raised to 3x. So what is the formula here to find particular integral? Just we prove. So that is what? 1 upon f of d e raised to x is equal to 1 upon f of a e raised to x. So this is the formula here. Formula. So put d is equal to this a, we get solution. Put d is equal to a, we get solution. So put d is equal to 3. D is equal to 3. So we get here 1 upon 3 cube minus 3 into 3 square plus 4 e raised to 3x. E raised to 3x. So 3 cube minus 3 cube get cancelled. So what is this? Particular integral. So that is e raised to 3x divided by 4. Divided by 4. So what is the complete solution? The complete solution is what? Complete solution is what? Y is equal to CF. CF plus PI, particular integral. CF plus PI. What is CF? CF is this. So that is C1 plus C2 x 2x plus C3 e raised to minus x. So this is CF plus PI. PI is this. E raised to 3x divided by 4. E raised to 3x divided by 4. So this is the solution of this differential equation. Okay. So finding a complementary function, particular integration, and adding them, we get a complete solution. So for more practice, we take more example. So it is necessary how to find particular integrals. So that is difficult one. So to find complementary function, so that is very simple. But particular integral is difficult. So we take more example to the next lecture and make easy to find particular integral. So we stop here. So I request you to getting more lecture of differential equation. You subscribe the channel and like also. So thanking you. Okay.